All right, let's look at number 19. So for 19, remember that you cannot integrate when you have a quotient. There's got to be some way that you can rewrite your integrand so that you don't have to divide. So you could either break this up into separate pieces over that common denominator, as I've done here, or some of you like to take that square root of x in the denominator and make it x to the negative 1/2 in the numerator and then distribute it through. That would be fine as well. Either one of those is going to work, whatever you like better. So if we go through and we simplify each piece of these, remember that when your base is the same and you're dividing, you subtract your exponents. So 2 minus 1/2 is going to give us the 3/2. 1 minus 1/2 is going to give us 1/2, and then the x to the 1/2 in the denominator can move up to the numerator with a negative exponent. Now we have not integrated yet. All we've done is simplified to get it to the point that we can integrate it. So now we can go ahead and do our antiderivative. So for your antiderivative, you've got your 3/2, add 1 to that, that would be 5/2. And then divide by 5/2. Dividing by 5/2 is the same thing as multiplying by 2/5. So there's the 2 that we already had out in front, and then our 2/5 x to the 5/2. For the next piece, x to the 1/2, add 1 to that, and that would be 3/2. And then dividing by 3/2 is the same thing as multiplying by 2/3. So there's the 3 that you had out in front, and then there's our 2/3 x to the 3/2. And then we had x to the negative 1/2, so add 1 to that, that would be x to the 1/2. And dividing by 1/2 is the same thing as multiplying by 2, so there would be our 2x to the 1/2. And then don't forget your arbitrary constant, your plus c. At the very bottom of the last page of the test, I wrote you a little note that says, is there a particular letter of the alphabet that you need to remember? So hopefully that will prompt you to go back, and if you've forgotten any of your plus c's, that you can put them on. But please remember that when it is a definite integral, when you have numbers here and you get a number as your answer, you don't have an arbitrary constant with those. You don't put a plus c with those. All right, and then our last one was our bonus. So let's look at that one. First off, I need to remember from pre-cal the Pythagorean identity, sine squared plus cosine squared is equal to 1. So if I subtract cosine squared from both sides, then 1 minus cosine squared is equal to sine squared. So I'm going to replace 1 minus cosine squared with sine squared. Now at this point, there are two different ways that you could do this. You could break this apart into separate pieces where you've got cosine over sine times 1 over sine, because cosine over sine is cotangent and 1 over sine is cosecant. If you do that, then we have a formula for that, right? The antiderivative of cotangent cosecant is just negative cosecant. The other way you could do that is with u substitution. So if you let u be equal to sine x, the derivative of u would be cosine x. So then the differential du would be cosine x dx. So this sine becomes u, so that's u squared, and then the cosine x dx becomes du. So we have just u squared du. So this u squared that was in the bottom, when we move it up to the top, we can do that with a negative exponent. So we'd have u to the negative 2 and then our du. And now you can go ahead and do your antiderivative. So if we add 1 to that, it would be negative 1. So I would have u to the negative 1 divided by negative 1. And so negative u to the negative 1, we replace the u with the sine x. And sine to the negative 1 is just cosecant. So either way, you're going to get the same answer with that. And that was where we stopped. We did not go any further with those problems.